This chart tracks unemployment in Pakistan, and it reveals a punishing economic paradox. The national average sits at 6.3%, but for university graduates, that number spikes to 16.1%. Holding a degree actually increases the likelihood of being unemployed. In computer science, the penalty is even steeper. Over the last 2 years, unemployment among these specific graduates climbed to 22.6%. The software industry, however, is desperate for talent. The National IT Association reports more than 20,000 unfilled jobs right now. They cannot fill them because they evaluate only about 10% of the 25,000 annual IT graduates as actually employable. The graduates exist and the vacancies exist. The disconnect happens inside the curriculum. Faculty members design courses around printed textbooks. They rarely have the time or a systematic mechanism to track the specific software frameworks and workflows that corporate recruiters demand this quarter. When course updates move at the speed of academic bureaucracy and industry evolves at the speed of software, the university degree stops functioning as a reliable bridge to employment. The obvious modern reflex is to outsource this curriculum update to AI. You take a 500-page technical textbook, upload the PDF into a standard large language model, and ask it to write a syllabus. A single prompt cracks under the weight of that task. It hallucinates chapter references and invents fake page numbers for required readings. The model's context window simply cannot hold the logical thread across hundreds of pages of dense technical theory. By week 8 of the generated syllabus, it forgets the prerequisite concepts it assigned in week 2. Furthermore, a static language model operates on historical training data. It has no live awareness of which specific tools a financial firm or a healthcare startup is actively hiring for today. Designing a rigorous, auditable curriculum requires distinct, specialized skills. It requires strict task decomposition. EduForge solves this through a multi-agent pipeline built on Google's Agent Development Kit. It splits the workload across 5 specialized agents, starting with how it reads the book. Instead of dumping raw, noisy text chunks directly into a prompt, a dedicated WikiBuilder agent reads the textbook chapter by chapter. It performs an automated literature review, pulling out key terms, summaries, and prerequisites. This process creates a highly curated knowledge store, mapping out every core concept into an interactive network graph. To make this data accessible, the pipeline routes it through a Model Context Protocol, or MCP, server. This acts as a strict, queryable bridge for all the downstream agents to safely search and retrieve verified textbook excerpts. By structuring the raw data before generating a single line of coursework, the system neutralizes the primary hallucination risk. It establishes an absolute, retrievable ground truth. But the textbook is only half the equation. A relevant course also demands external context from the real world. A dedicated research agent executes live web searches to extract the specific workflows and software frameworks that employers and the target industry are asking for right now. At the same time, a standards mapper evaluates the plan against local academic accreditation requirements, aligning the curriculum with stringent university learning outcomes. Because these two tasks do not depend on each other, the pipeline runs them concurrently as parallel agents, cutting the processing time in half. This fuses live industry intelligence with academic compliance, yielding a structural foundation that answers to both corporate recruiters and university regulators. An outline architect agent then synthesizes the curated textbook wiki, the web research, and the academic standards into a high-level 14-week course skeleton. Then, the pipeline deliberately halts all execution. It refuses to generate any specific weekly content. This pause is a strict pedagogical requirement. A human professor must step in to review the macro structure, ensuring the pacing and workload are actually realistic for undergraduate students. This checkpoint places human judgment at the point of maximum leverage, long before any expensive computational resources are spent drafting the granular details. Once the professor approves the skeleton, a problem setter agent loops 14 times. For each week, it writes an industry-specific case study, a research task, and a practical assignment. Before compiling the final blueprint, every single week must pass through a QA readiness score. This stage operates under a strict scientific constraint. The language model that wrote the curriculum is explicitly forbidden from grading its own work. Instead, The score makes 0 model calls. It operates deterministically, taking the generated text and querying the database to compute top hit similarity against the original book. By removing generative AI from the evaluation phase, the system provides a mathematical guarantee that the resulting syllabus is firmly grounded in the source text. We can examine the results by looking at a course built from a 500-page textbook on large language models, specifically targeted for the finance industry. Week 5 of this generated blueprint assigns a highly specific practical. Students are tasked with fine-tuning a model using LoRa under strict compute constraints to process financial data. Directly beneath the assignment, the syllabus directs students to page 211 for their required reading. Because of the deterministic quality check, we know this is not a hallucination. The database verified that page 211 is precisely where the author actually introduces the mathematics of LoRa. The pipeline successfully fused abstract mathematical theory with a concrete corporate use case, citing the exact pages without inventing a single reference. This entire architecture was built to operate under severe engineering constraints, caching data to disk at every stage, so it can run entirely on a free tier API budget of 20 daily calls. It compresses the grueling labor of reading a dense PDF and researching current job markets into a single afternoon. That efficiency translates directly to the students sitting in labs across developing markets, whose economic futures depend on acquiring relevant skills. A single faculty member, armed with an open-source tool and a free API key, can now match the curriculum agility of the world's most resourced universities. By treating course design as a rigorous data routing problem, we can begin to close the gap between what academia teaches and what industry demands, one course at a time.